talked about frequency distributions. We talked about class widths, class boundaries. What else did we talk about? Anybody gonna talk to me? What else did we talk about? Lower class limits and upper class limits. So we basically went through and we did all of that, and then we started talking about center, right? And I told you that the basis of all statistics is based on what? The center. And we talked about what an outlier was. What's an outlier? 200-pound second grader, right? At 1800 SATer, right? Those are your outliers. In other words, people that, you know, are things that don't come along every now and then, or that come along only every now and then. 6 foot second grader, 200-pound second grader, whatever the case may be. You ever seen somebody that has a blue eye and a gray eye? You ever seen somebody like that? Or somebody with a birthmark halfway across their face? Or somebody with one ear? You know, things out of the norm are usually going to be out of center and outliers. I think we got to this page right here. Did we not? Page 44? I think we got somewhere right in there. So what determines center? Well, center is determined by the mean. And that's why everything about statistics is about the mean. Mostly everything. Revolves around the center. And the center is usually 90% the mean. And I'm just saying 90%. In this class, most of the time, you're going to be able to find the mean based on most of the time, everything around this class is going to revolve around the mean. Now, of course, you're going to get into other statistics. Some of you business majors will get into statistics where they revolve around the median and that kind of thing. So, but my point is on this definition is everything revolves around the center. So if you can find the mean in this class, then you're good to go. But remember, I told you there's two types of data. There's two types. There's your listed, I just call it listed data. And then there is the frequency distribution. Now listed data, everybody's done that before. What have you done your whole academic career at the end of the semester? What have you done to find the mean? What have you done? You found the average of what? Average of your test grades, right? Everybody's done that. Everybody knows how to do that. And that's an example of listed data. The average age in the classroom, listed data. Each one of you have a age, and I listed on the board 25, 26, 28, 22, 16, whatever the case may be. And we take average of this classroom. That's all listed data. But the frequency distribution, that's where some people go, oh, okay, I don't know how to do that. Usually, to some people, that's a big question mark. So you need to be able to learn how to do both. Okay? Because not all the time are you going to be given listed grades or listed ages or listed whatever. Because it takes up too much space and too much time. Now, the other thing that goes in correlation with the average, sorry, is the standard deviation. Yes. Now, some of you may have had 120 before in high school, and you got the standard deviation, no problem. It's a tedious process by hand. And some of you may remember what it stands for. But some of you haven't even done this before. You sure as heck haven't done the standard deviation of a frequency distribution before. In other words, I doubt very seriously that somebody says, oh, I took Math 120 and we only did average and standard deviation of frequency distribution. We never did this. I doubt very seriously you did that. Most of the time, it's the other way around. Most of the time, the teachers cover and hound you on this, and you don't touch up on this little much. Okay? So that's the two things that you need to be able to do in order to survive this first unit test. You need to be able to find the mean and standard deviation of a listed group of data, and you should be able to find the average and the frequency distribution of a frequency distribution. Okay. Question on that? Of course, we're going to do that. And they might get, I don't think they're going to get into chapter 2. It's usually chapter 3 they get into. But and they talk about a frequency distribution here. And there's the definition. Make sure you know what the definition is. I think we covered that yesterday, meaning the day that you were here last. I don't need anybody saying, we didn't come yesterday. I know that. Shut up. Okay? I mean, the last time you were here. What day was that? Monday. So, you know, make sure you got that definition in your head or in your notes or somewhere. Midpoints are going to be very important. So you might want to write that down somewhere. That's your midpoint. That's going to be your, that's to do the standard deviation and the mean of a frequency distribution. You're going to have to find the midpoint. So make sure you put a star beside that. We've already covered those. But make a note, page 45, those definitions are important. We covered that yesterday, Monday, so check out the video Monday. I hope I posted it. I think I did. Tried to. And the class width, I told you how to find the class width. And they're showing you more frequency distributions. I'm not really too concerned about that. When I see something important, I'll let you know. Right now they're giving you enough examples to choke on. Okay, that takes care of 2.2. 2.2 is a very important chapter or section, so you might want to put a note beside 2.2 say make sure I know this material, because that's a lot of information for your 20% on your Unit 1 test. 2.3 histogram. I told you the other day that a histogram is nothing but a what? I think I told you. I might not have. It might have been the 103 class. What? A bar graph. And what's the difference between a bar graph and a histogram? The histogram, the bars touch each other. That's the difference. So a bar chart and a histogram are basically the same thing. One, you have a space between the bars. Two, you don't have a space between the bars. Bar chart, histogram. I'm not going to spend a lot of time on that because I don't want to insult your intelligence. These are histograms. Why are they histograms and not bar charts? Because they touch each other. Right here, right here, right here. Right there, right there, right there. They don't have a space between them. Now the only thing you got to remember about a bar chart or a histogram is the height that the boxes are is the frequency or the head count that you need to know about. So this one is probably like, well, you have to have little marks over here to understand this needs to be graduated. That looks like about a 2. That looks like about 32, 33. That looks like about 34, 35. That looks like about 5. And that looks like about 1. But I'm not able to tell because these are not graduated over here. I don't have any little tick marks between 0 and 10. So you just got to use your best judgment when you're dealing with one like that. Same thing here. This looks like about 2. Looks like about 41. About 43. About 7 or 8. And about 1. So if you want to know the total, what do? You add up those numbers. What did I say? 2 here, 41 here, that's 43, plus 43 is 86, plus 7 is, I have no earthly idea, what, 83? I don't know. Plus 1 is 84, so 84 is in. You add them up. Okay? And no, I can't add very well. Alright. And that shows you how a bell curve looks with a histogram. That basically looks like a bell curve. Skewness. Sorry, I'm too puberty. Skewness. If data is skewed to the right, that means it's heavy on the left. If data is skewed to the left, it's heavy on the what? Right. Remember that. It's always the opposite. If data is skewed, if it's skewed right, the data is heavy on the left. If it's skewed left, the data is heavy on the right. This is a histogram showing normal what? Distribution, normal curve. This is a histogram showing not much variation. What's not much variation? Well, there's not a big curve. What is it doing basically as you go from left to right? It's a straight line. It's staying the same. So there's no variation there. So the histogram on the left depicts a normal distribution. The histogram on the right depicts no variation. This is skewed right. This is skewed left. Skewed right means that all your data is on the what? Left. Here's the center right here. Skewed right means that all your data is on, skewed left means all your data is what? On the right. Make sure you know at least 3 of those. I think you can figure out which one I think are important. This one, and this one. And yes, I'll give you that on test. I'll show you a picture and you just tell me what it is. That's 2.3. I think we go to 2.4, don't we? What is 2.4? 2.4 is graphs. All right, these two graphs on page 61 are called scatter plots. Scatter plots is when you take data and you basically put it on the XY axis, XY graph. And then you look at the data and you say, this is what's happening. So that's basically it. What's happening on the left side right here? What's happening right here? You have a correlation going what? Left to right, a positive correlation. Meaning correlation is a 25-cent word for tendency. Okay, there's a tendency to go left to right what? Up. Left to right up means a positive slope or a positive tendency or a positive correlation. What does this one kind of show? No correlation, or you could say a slight what? Slight negative correlation. I don't know what they're telling you, what it don't say. I don't see anything that says they're telling you what it is. So it looks like to me that you could get a negative correlation out of this one. If you drew a line, least squares, the line of regression, the least squares, it'd be looking like that right there or something like that. And this one would be left to right up. No correlation would be all over the place. Just all over the place. In other words, if you try to draw a line between them, or with at least regression, you could not, it would just go like straight across. Alright? I'm not going to try to trick you on that. If I gave you one of these, you'd be able to tell if there was a negative correlation or a positive correlation. You could say that is a no correlation because it's all over the place. But I wouldn't give you one that was tricky. I'd give you one that was pretty straightforward. Remember, Chapter 1 and Chapter 2 is only 20% of your test. I'm not going to spend a lot of time trying to get you to fail Chapter 1 and Chapter 2. Chapter 3 is what is the meat of Unit 1 test. So don't worry about Chapter 1 and 2 that much as far as being able to do it. Make sure you know what a stem plot looks like and make sure you know how to get one. I mean, it's not hard. How do you do a stem plot? You basically list on the left side of the stem plot, the base 10 of your system. Let's say you have the lowest IQ score is 50, the highest IQ score is 140. Then you're going to put on the left-hand side 50, 60, 70, 80, 90, 100, 110, 120, 130, whatever the case may be. So that's going to be your left-hand side. You're going to leave the zeros off because that's the way you do a stem plot. Those of you that don't have a book, I'll try to blow this up for you. It's on page 63. See how they've basically listed the units on the left-hand side? 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. And then they go through the list and find out how many people are 50. Well, that's not 506. There's a 50 and there's a what? A 56. In the data, there's two numbers that are 50 and 56. So they take those two sets of data, and they put a 0 and a 6. Is there any 60s? No. With 70s, you start to see a lot. There's 70, 72, 73, 74, 75. There's 5 or 6 76s. There's 2 77s, and there's a 78. And of course, we see what type of shape. What type of shape do you see if you turn it? If you flip it, what type of shape do you see? A normal distribution. Okay, or a bell curve. So make sure you can do a stem plot. And there'll be some homework problems showing you how to do that. And on a scale from 1 to 10, they're about a 1. I mean, they're very easy to do. Another Pareto chart, pie chart. Make sure you know how to read a pie chart. A pie chart is usually based on what? Percentages. Okay? And they will ask you, usually you see a pie chart is based on percentages, usually has something to do with income. I make $1,000 a month and I spend 8% of my money month on gasoline or fuel. So that would be 8% times 1,000. What would that be? Well, 10% of 1,000 would be what? 100. 1% would be what? 10, Hubert. That's right, class. So what would 8% be? Well, 8 times 10 is $80, Hubert. That's right, class. So if I spent 20% of my income on eating out, what would that be if I make $1,000 a month? $200. And that's how you read it. Again, I'm not going to insult your intelligence. Most of you graduated high school. Most of you should be able to read a pie chart. Just like you should all be able to read a tape measure, but that's not possible either. Right? Some people have no idea how to read a tape measure. Some people don't even know who the first president of the United States was. You ever seen Water's World? It's pitiful. It's pitiful. Those people should be taken out and shot. They should. All right. Pictographs. You got to watch pictographs. Why? You might want to put a note beside pictographs. Pictographs are the best way for people to be dishonest with statistics. Why? Because there is no analytics to a pictograph. What's the big difference between engineering majors and art majors? Well, engineering majors are very what? Analytical. Art majors are very what? Non-analytical. Alright, so what I'm trying to tell you is art and science don't usually what? They usually don't jihad. Jihad is an actual word. You know what jihad means? Anybody? Jihad is what you use for a mule. G means left, ha means right. Jihad. That's what it means. So write that down. It doesn't have a thing to do with mathematics. It has to do with something that you ought to know in real life. The word jihad means tell the mule to go left, tell the mule to go right. When people say you don't talk to a mule, you don't talk to a horse either, do you? Whoa. What does whoa mean? Stop! You talk to a horse, talk to a mule too. And that mule turn left or right based on if you say G or ha. And that's where the word jihad comes from. That's where the slogan jihad comes from. And if you didn't know that, it's your parents' fault. Okay. I say that a lot. So don't go home and tell your parents that I was talking about them. I say that a lot. Okay? Don't I, Mr. Robinson? Okay. You know to say yes, sir. That's what I pay you for. All right. Pictographs. They don't jihad. Why does art and science, why do they not jihad too much? Because art is very non-analytical and math is very what? Or science is very what? Analytical. What does analytical mean? Analytical means either it's yes or what? No. Non-analytical means, well, it's basically how you interpret it. Okay? Why are pictographs not very reliable when it comes to mathematics? Why? Because it's all how you interpret it. What would you say on a mathematical note? What would you say about these two pictures right here? Would you say that the one on the right is twice as big, 3 times as big, or 4 times as big? That's not rhetorical, I'm asking you now. Now, when she said that, what did she say? Why did you say I say? Why did you say 3 times as big? Exactly. That's the way you interpret it. I guarantee you somebody says, looks like 4 times as big. That's why pictographs should not be used. Pictographs should not be used in statistics. But who uses them? People that don't understand statistics. That's who uses them. And you put that picture on there and say, this many people are flying in 2000, or this many people was flying in 2001, this many people were flying in 2010, or 1994. Okay. Well, good gracious, it looks like everybody's flying in 2010, but the actual mathematics could just mean a third, or 3 times as much, or 2 times as much. But that pictograph looks like 4 or 5 times as much. That's why you got to stay away from pictographs when you're talking about presenting material, unless they're scaled. Now, why would I throw that word scaled in there? Because scaling the pictograph narrows the interpretation, what? Narrows it down. You can't do a scaled representation and be biased. The scale doesn't let you do that. But pictographs, some of them aren't scaled. You'll see a lot of these in newspapers and on TV shows. Why are TV shows and newspapers you got to watch out for? Why you got to watch them out? Why would they be prone to doing pictographs? What majors go into newspaper writing and article writing and TV? Engineers? No. Who goes into those two professions? Huh? English majors, which are, is that science or art? Art. Self-explanatory. So watch it. When you're looking at a pictograph, I don't care where it is. Be careful, because it may be not correct. It may be inaccurate. Where this one would be much more accurate. Why? Because it's scaled. It's scaled down to your graduated parts over here. It jihaws. Conclusion. Get a science major and you'll be okay. No, I'm just kidding. I'm just saying, be careful when you're dealing with numbers. Are numbers important? Yes or no? What drives every business in America? What are the numbers called? Money. Everything in America is driven by money. Everything in the world is driven by money. Think about it. You take any profession, and somewhere in that profession it's driven by money. People can say money's not important. That's bullcrap. It is. Now, we obsess over it? Yeah, we do. But is it important? Yes. Okay? I don't care what profession you go into. If you don't know the numbers, if you can't discern from the numbers from reality, then you probably are not going to go very far in whatever career you're in, because it's what drives everything. So make sure you can look at two things and be able to tell the difference between the two. Is that 2.4? Okay, we're through with chapter 1 and chapter 2. So everybody's ready for a test. I'll give y'all a test right now. Okay? Here's a good example right here. Subway fare. In 1986, the New York subway fare cost $1. And as of this writing, it now costs $2. So the price is doubled. Is this a good way to show it? No, it is not a good way to show it. Is this twice as big as this? No. You could fit probably 4 of these into this. So that is incorrect. Here's another one. 7 or 8 million barrels of oil per day. 21 million barrels of oil every day. So if you are comparing oil, is this a true statement? Well, first of all, how many times will 8 go into 21? Twice, maybe 2.5. So we're talking double the size, right? Is this double the size of this? No, I think you can fit probably 8 of these into this. So that's incorrect. And most of the time, see, I can tell you right now, this one's not going to be incorrect unless it's just drawn wrong, because you got your graduations over here and you're drawing these to the graduations that you're supposed to. So I doubt very seriously that this one's going to be wrong or inaccurate. Where these two, you can almost bet your bottom dollar that these two are going to be inaccurate because of pictographs. Now you can do pictographs if they are scaled. If they are scaled to be, if it's 3 times as much, then you need to measure the length of this guy, and if it's 1 inch, then this one needs to be 3 inches because it's 3 times as much. So you need to look at it. Because that's the type of problem I would give you on a test, is these 2 right here, or one of these 3 right here, if I gave you one of these. And if I gave you one out of these 3, it would be a pictograph, because you need to be able to see if there's a difference or not. Because these are the ones that you see every day via the newspaper and via on the news channel or whatever you watch. Okay? Hopefully you don't watch some of the same TV that Waters World watches. Is it Watters? I think it is. Let's see real quick. So that one person that's going to complain can complain, give them something to complain about. That's just Google. I don't have a Google board there, I need. There it is. Golly. It was on there. This was the latest version of Waters World.
The Goldman Sachs 10,000 Small Businesses program provides business skills to entrepreneurs. It was the first program that really brought together all the skills that I needed to work on, and the knowledge I needed to run my business. See how small businesses are driving economic progress in their communities.
Back in the book segment tonight, Waters World, the X Games edition. We sent Jesse Waters out to Aspen, Colorado, very chic, to check out extreme snowboarding and skiing. But of course, this is not Wide World of Sports here. Waters had another mission.
Tell me the vibe of the X Games. Everyone comes together, excited about snow, excited about catching some big air. Are you cold?
Just my fingertips.
Just the tips?
Just the tips.
Just for a second, just to see how it feels.
First president of the United States.
Oh, God. I have no idea. That is a great question. I have no idea.
George Washington?
George Washington. George Washington.
George Washington.
Good. What's up?
And when was he president?
1776?
1900s? I don't know. Way before I was born.
Like the 1910? 1983. No. I want to party with you, cowboy.
What countries did America fight in World War II?
Spain? Germany.
Who else did we fight?
France.
Japanese guys. I don't think Poland was a part of it too much, but I heard some rumors, so.
Mainly we were against Germany.
Russia? No.
Who bombed Pearl Harbor?
Put me on the spot to where I go blank.
Was it China?
Korean. Who was president during World War II? Winston Churchill. Are you British? No.
I get it. I have bad teeth.
During World War II, I think it was Bush. Am I close?
Nixon?
FDR. And Truman. Lincoln. Lincoln? I don't know. That was the Civil War. What body?
I don't watch this very much because it irritates me. Anyway, you see why I don't watch it. But anyway, hopefully y'all can be smarter than those people and tell the difference between the two. Nobody's going to comment at all. Okay. All right, so that's chapter 1 and 2. Everybody feel good about it? Okay, nobody's going to talk to me. Then what are you going to do in chapter 3? Well, chapter 3 is where we get into the good stuff. That's when we get into the chocolate chip cookies. Wouldn't you love to have a bunch of chocolate chip cookies right now? Especially like that with the chocolate chips melting. I wish I had some. Chapter 3. This is where you need to start taking notes because this is what's going to be detrimental on the test. Measure of center. We've already talked about measure of center, but they're talking about the mean. Well, we've already talked about the mean a little bit. How do you get the mean? Well, that's what we're going to talk about. There is the formula for the mean on page 81 down at the bottom. Highlight it. Make sure you know it. Now, all of you know it. You just don't know how to write it. Well, there's how you write it. You sum up all the numbers and you divide by what? How many numbers there are, Hubert? That's right, class. And that's how you do it. The summation of all your numbers, and that big backwards looking E looking thing, that's sigma. That means summation. Write that down. Summation. Summation. That means you add them all up. Add up all the numbers and then divide by how many numbers you got. And N is how many numbers you got. Also highlight what I told you about parameters and statistics. Sample statistics, S, sample, S and S, usually are represented by English letters such as X and S. I told you that, X and S. Where population parameters are usually represented by what letters? Greek letters. Mu and sigma. This is uppercase sigma, lowercase sigma is little O looking thing. And there's some examples right there. Now most of you can find the mean, but if you can't find the mean, page 82, there's an example, example 1. Again, I'm not going to insult your intelligence by making you do example 1, but if you can't remember how to get the mean, that's how you do it. The median. What is the definition of the median? Well, what is the median in the highway? The middle. So if you put your numbers in order, which you always do when you're working with these things, you always put your numbers in order. Your numbers in order, the middle number is going to be your median. Now you've got to remember the 2 rules about median, and there they are, 1 and 2, so highlight them. If you have an odd amount of numbers, in other words 15, 17, 21, 23, 25, 27, 33, 35, 39. If they're odd amount, then you take the middle number. What if they're even? You take the mean of the middle two numbers. And you need to write that down. And that's what that one's saying. Most people know how to find the mean, but they forget about this rule right here. And there's example 1, example 2, and example 3 are good examples because one is odd and one is even. What is the mode? Most. Mode and most. Remember mode and most. M-O, M-O. Mode, most. It shows up the what? Most. The number that shows up the most. This is the only one that's not calculated. You have to look at the mode. You have to look at the data. Can the mode be more than one number? Yes. If you have 3 45s and 3 32s, then your mode is 32 and 45. If you have 5 52s, then you don't list those two as the mode. You list the one that shows up the most. The 52 would be your mode. Bimodal means you have 2. Trimodal means you have 3. Polymodal means you have more than 3. Multimodal. Some say polymodal, some say multimodal. We're not going to have to worry about multimodal or polymodal in this class. What if you do not have a mode? You put 0? No, unless you just want to get something wrong. 0, you'll have an SA teacher mark it wrong and say, 0 is not even listed. I'm just telling you, you will. Do not put 0 because the SA teachers will mark it wrong. Uptight teachers. They're uptight. You know, sign, so forth. Okay? Put no mode, not applicable. There ain't none. Put whatever you need to put, but make sure it's words and not 0, because I'd hate for you to go to Clemson and take business statistics, math science 301, and put 0 down and get it wrong, and the teacher just put a little smart comment beside it saying, where did you get 0? It's not even listed in the data. I'm just telling you. Uptight. Do I care about the mode? No. Do many people care about the mode? No. It's really not that big of a deal. It's a measure of center, yes, but we don't rely on it. What do we rely on? We rely on the mean and sometimes the median, but mean mostly. Capiche? Mid-range. Mid-range is important. Where? When you're doing a box plot. The mid-range is very important. So put a note beside mid-range. Used later for box plot. You're going to use it about 5 or 6 times for each box plot that you do. And I'll show you how to do that. Is it important for the mean and the standard deviation? No, it is not. Round off rule. Okay, we're going to go on record right now and say this will answer your question about rounding. Because some of you are going to say, well, I did this problem and I got it wrong, but it's almost right. Well, you didn't follow this rule. And the rule states that for the sorry, thought I was blowing it up on my screen. For the mean, median, and mid-range, carry one more decimal place than is present in the original set of values. So if all your values are whole numbers, what are you going to put the range, mean, median, mid-range, what are you going to carry it to? One decimal place, meaning the tenths. So if it's whole numbers, tenths. If it's tenths, then it's going to be to the hundredths. If it's hundredths, then it's going to be to the thousandths, and so on. Most of your problems in this class are going to be whole numbers or tenths. For the mode, leave the value without rounding. Duh. The mode is 30. I'm going to change it to 30.1. Okay, what did I tell you about the mode? It is the only one that's what? Observed. It's the only one that's not calculated. So if it's not calculated, why are you going to change it? Okay? Just put 0. Alright? Now a lot of you saying, Hubert, I thought we were going to do some math. Just chill out. We're going to do some here in just a few minutes. Class size. I don't really worry about that right now. Okay, here we go. Now we're talking calculating the mean from a what? This is where some of you start to lose you. So let's be very, very, here we go, careful here. Write down this definition or formula. The mean, the mean of a standard, of a frequency distribution is as follows. Write that down. X bar, which is the mean, is equal to the summation of f times x over the summation of x. Now half of you are going, okay, I remember that from high school, and half of you are going, it's Patrick Starfish, I have no idea what that means. Well, f is your frequency, that's your head count. So write that down, head count. X is your midpoint, which I told you that we were going to have to find the midpoint. And summation of f is your summation of your head count, which is n. So what I would like to do is find a table, and it's giving us a table. The first two columns of table 3.2. That must be on the next page, or it's on this page. Is this table 3.2? Here we go. Alright, so let's write down this first two columns of this table right here. So, I'm going to just write down an IQ score and number. Meaning the number of people that had that IQ score. 50 to 69, we had 2. 70 to 89, we had 33. 90 to 109, we had 35. 110 to 129, we had 7. 130 to 149, we had 131. So let me make sure I wrote that down right. 2, 33, 35, 7, and 1. Okay. This is what you're going to be given on the test. Alright, everybody with me? So this is a frequency distribution. And you want to find the mean. The first thing you do is you erase this guy right here and put F, because that's what this is. There's your F's. The next thing you do is you draw another line and you call it X, and you find the midpoint of these two numbers. Now the midpoint's easy to find. All you got to do is find one number, and that's the first one. Once you find the first one, then you add the class width. What's the class width? 20. So you just add the class width each time. So let's find that first midpoint. So 50 plus 69 over 2 is equal to, well, 50 plus 60, that's 119 over 2, which is equal to what? 59.5? That's your first midpoint. And now you just add what? 20. So that'd be 79.5, 99.5. 99.5 plus 20 is what? 119.5? Plus 20 is 139.5. Now how difficult is that? Make sure I did it right. That's how you find the midpoints. Now make sure, you got the video, but make sure you write down in your notes what I just did. I took the midpoint of the first one, 50 plus 69, divided by 2, and I put it right there, and then I just started adding 20, which is the class what? Class width. Now, the formula said the summation of f times x over the summation of f. So that's our formula for the mean. So we got to add another line or another formula. This is when I usually pull up the Excel spreadsheet, but I get chastised so much for that, I'm about ready to quit doing it, because I get somebody moaning and complaining that I'm trying to make y'all do Excel spreadsheets. So this is what you get. You're going to get me drawn all over the board. But I'm not going to do it forever, because some of it gets so long and so drawn out that I am going to use the Excel spreadsheet. And some of y'all can just, I hate it. Alright, so what's this column going to be called? F times X. Good. Some of y'all remember from probability. So F times X. I better not write it like that, because some of y'all might think it's a function, so I'm not going to write it like that. F times X. So I'm not going to do it because I don't have a calculator with me. 2 times 60 is 120. So that'd be 119.5. Huh? Okay, 0.0. And so on. That's why I'm using Excel spreadsheet. Now, I'm trying to make y'all use Excel spreadsheet before I'm done. So, we'll do those. Now, what does this say? The summation of f times x. So what am I going to do with those numbers right there? I'm going to add them all together. And that's going to be your numerator. And then what's your denominator? Well, your denominator is going to be right here. Add all those up. Well, 30 plus 7, 33 plus 7 is 40. And 40 plus 35 is 75, 78. And that is your denominator. And then, of course, you put the numerator over the denominator, and that is your mean. So finish that. Take the calculators out and punch it out. Because I'm not going to do it on the Excel spreadsheet. I'm going to call the roll while y'all doing that. Today's 28th. All right, Bailey, Bolt, Clayton is here, Cowart is here, Dutchke is here, Escobar, Farr, Freeman, Hammett, Harris, Harvey, Hayes.
Here.
Did you sent me an email, did you not? You have to remind me what it is. I can't remember. I think it was you're not going to be here on a certain day or something. Okay. Oh yeah, I need to tell you I'm going to throw you out of class. That's what I'm doing. All right. I did remember you. I did remember your email. I'm trying. All right. Johnson, Mullins, Murray is here. Newton, Poor. Hello, Poor. Perdesi. Okay, I got all my Robinsons here. Miss Robinson left early, but all my other Robinsons are here. Miss Scarborough is here. Schuler. Simpkins. Shadu. Is that better? Okay. Smallwood. My Vones are here. Williams and Wood. So the only person not here today is Mr. Poor. All right. Submit, and hopefully y'all won't get an email this weekend. Let's check your attendance. No, let's go back and check it. Yep. Okay. So y'all won't get any nasty emails this weekend. At least I hope you won't. In the future, if you ever get an email that says that I didn't take a roll or that I marked you absent, then when should you discuss it with me? Take a guess. The next class. Good job. Because it's not that detrimental, okay? You don't need to spend all weekend worrying about it. You don't need to spend all weekend writing me 3 emails, Friday, Saturday, and Sunday. You don't need to stay up late at night worrying about it. You just need to see me at class and just say, what's up with this? Okay? All right. So, what'd you get? Well, let's just go back and look at the book, because I'm not going to do it. I'm just not going to do it. There you go, F times X. They get 7201 and 78. We got 78, I think. And divide those two, what do you get? And that's your mean. That is the mean IQ score of all those people. Now, what's different than this from what you're used to? What are you used to doing as far as the mean goes? You're used to having all the numbers. Remember that box of what was it called when you got the end of chapter 2? What did I call it? Box and Whiskers, Box and... Yes, Tim and Lee. That was this, wasn't it? I believe it was. I believe that was the same as this one. Because I remember there was two. There was a 50 and a 56, wasn't there? I believe that's these. And I believe those bar charts were the histograms were showing this also. What does that have to do with it? Well, if you go back to the stem and leaf, that's what you're used to finding the mean of, all those numbers. Here, you're not given those numbers. You're only given how many are in this range. But you still can find what? The mean. And it would be interesting to see what the mean is of that stem plot. Somebody tell me what number that stem plot's on. Anybody remember? Chapter 2, isn't it? 63, thank you. I hope that's it. It may not be it. I just may be thinking in my head. I don't know. Count how many's. I don't know. We need to count how many's in there. I'm just curious. Was there any in the 60s? Look in the note. I mean, your note. Look at our. Okay. What about 60s? Okay. Okay. So that's those two. And then what? 70 what? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 35. What'd you get here? 7 and 1. Does it match? That tells you how my brain works. I remember that. That's kind of weird, isn't it? All right, now take these numbers and find the average. See what the average is. Write it down if you have to. You don't have to worry about the fields, or not fields, the classes. Just write down 50, 56, 70, 72, 73, 74, 75, 76, 76, 76, 76, 76, 77, 77, 78. Do that right quick. Take a few minutes. And let's see how close the two means are. Take your time. They took care of the cricket. You'll know you don't hear the cricket anymore. The cricket was a belt on a fan in the maintenance room, which is on the other hallway over there, and it was going through the duct system. The sound was going through the duct system, and that's why it sounded like a cricket. It was driving me bananas. I don't know about y'all. No coughing in class. All you can do is breathe. Tell me when you get it a mean. And yes, there are 50. 50 numbers. Just shout it out whenever you get it. $92.8. And what page were we on with the example? How much? 78? 87? Okay. There we go. What did the mean come out to on this one? And you got 92 point what? 92.3, 92.8. What's the purpose of this? To show you what? There's not much difference, if any, between the two means. Now, let me ask you a question. Sometimes it may be easier to do it how? By the frequency distribution. Why? Takes less time and there's less margin of what? Error. Depending on the term. Pronounce it however you like. E-R-O-R. So, what I want you to be able to do so far in chapter 3, of course I know y'all know how to find the mean of a list of data, but make sure before you come back Monday next week, make sure you know how to do a couple of problems with frequency distribution, okay? Y'all get out of here and have a good day. Glad y'all got to see me today. Try this with the SD reader. See if I can. Watch the cord, don't fall over the cord. I don't want you suing me. Really? Didn't even put it on the SD drive, it's on the internal. This just pisses me off. Now you told me you had well, I understand. I got a 66-year-old. I I got a 16-year-old blaming me for everything. It's my fault. This happened. It's my fault that this happened. Girl or boy?
Boy.
Well,
I have 2 boys.
I tell you, sometimes I think it's better to have boys.
Yeah.
Girls are worse. So, well, just text me. Did you text me or email me?
I emailed.
Okay, just either one. Just let me know.
Okay. Okay. Thank you.
Bye-bye. Don't trip. That makes me so mad. When I didn't stop the